In this video, we will be going over how to factor trinomials. The first kind of examples we will be covering are quadratics in the form x squared plus bx plus c. These are quadratic expressions where the leading coefficient in the x squared term is 1. So if we look at this first example, x squared plus 3x plus 2, the leading coefficient is 1, since x squared is just 1 times x squared. We need to first look at the constant term, which is a 2, and we need to find two numbers that multiply to 2 and add to the coefficient in front of the x term, which is a 3. The possible pairs of numbers that multiply to 2 are 1 and 2, and -1 and -2. If we look at the second pair, -1 and -2, we can see that -1 plus -2 is equal to -3, which is not equal to the coefficient of the x term, which is 3. So this pair of numbers is not the right one. If we try the pair of numbers 1 and 2, we can see that 1 plus 2 is equal to 3, and that is what we want. So 1 and 2 multiply to the constant term of 2, and add up to the coefficient in front of the x term, which is 3. So these are the two numbers that we will use. So given the two numbers 1 and 2, the answer is x plus 1 times x plus 2. What we have done is taken the two numbers we have chosen and factored the expression as x plus the first number, which is a 1, times x plus the second number, which is a 2. The order in which we choose our numbers doesn't matter, as long as we have chosen the correct two numbers. The reason why this works is because if we expand our factored expression, we can see that it equals x squared from our first multiplication plus 2x from our second multiplication plus x from our third multiplication plus 2 from our last multiplication. And this simplifies to x squared plus 3x plus 2, which is what we started with. The coefficient of the x term is 2 plus 1, which equals 3, and that's what we have in our original expression. We can clearly see that this is the sum of the two numbers we have chosen, which was 1 and 2. The constant term is 1 times 2, which equals 2. This comes from the last multiplication when doing the expansion, and we can see that this is the product of the two numbers we have chosen. So let's do a few more examples of this kind of problem. Let's factor x squared plus 5x plus 6. So we need to find two numbers that multiply to the constant term 6 and add to the coefficient of the x term, which is 5. So the pairs of numbers that multiply to 6 are 1 and 6, -1 and -6, 2 and 3, and -2 and -3. Only 2 and 3 add up to 5. So these are the two numbers that we need to choose. Since a trinomial in this form can be factored as x plus the first number times x plus the second number, we can factor this as x plus 2 times x plus 3, and this is the answer. Let's do another example. We need to find two integers that multiply to the constant term 10 and add to the coefficient of the x term, -7. So we'll list out all the possible numbers that multiply to 10, which are 2 and 5, -2 and -5, 1 and 10, and -1 and -10. Notice that -2 plus -5 is equal to -7, so these are the two numbers we are looking for. This means we can factor the expression as x minus 2 times x minus 5, and this is our answer. In this next example, we need to find two integers that multiply to the constant -2 and add to the coefficient in front of the x term, which is -1. The possible numbers that multiply to -2 are 1 and -2, and -1 and 2. We can see that 1 plus -2 is equal to -1. So the two numbers we need to choose are 1 and -2. So this means the answer is x plus 1 times x minus 2. So let's go over how to factor quadratic expressions where the leading coefficient is not 1. Notice that the x squared term has a coefficient of 6 in the expression 6x squared plus 11x plus 4. This means the leading coefficient in the x squared term is not 1 like in the previous examples, so we will need to use a slightly different method. The first thing we need to do is multiply the coefficients of the first and third terms in the x squared and constant terms. 6 times 4 is equal to 24. What we need to do now is take this number and find the two numbers that multiply to 24 and add to the coefficient of the middle x term, which is 11. The two numbers that add to 11 and multiply to 24 are 3 and 8. We can see that 3 plus 8 is equal to 11, and 3 times 8 is equal to 24. What we need to do now is split the middle term using the two numbers we found, which was 3 and 8. This means we have to split 11x into 3x plus 8x. So we can rewrite the expression as 6x squared plus 3x plus 8x plus 4. So we can see that 3x plus 8x is equivalent to 11x in the original expression. The reason why we needed to split the two numbers to add to 11 in the middle term is so that we could split the term in this way. So now we can use factoring by grouping to put 6x squared plus 3x in a group, and 8x plus 4 in another group. So if we start with the first group, we can see that 6x squared and 3x both have a 3x in common. So if we take out a 3x from 6x squared, we're left with 2x. And if we do that with the 3x term, we're left with a plus 1. So if we move on to our second group, we can see that 8x and 4 have a 4 in common. So we'll take out a 4 from both terms. If we take out a 4 from 8x, we're left with 2x. And if we take out a 4 from the 4 constant term, we're left with a plus 1. So now we can see that both terms have a 2x plus 1 in common. So we'll take out a 2x plus 1 from both terms. If we take out a 2x plus 1 from the first term, 3x times parentheses 2x plus 1, we're left with 3x. And if we take out the 2x plus 1 in our second term, we're left with a plus 4. And this is our final answer. Let's do another example. The first thing we need to do is multiply the coefficients from the x squared term and the constant terms. So if we take 6 and multiply that by minus 2, we end up with minus 12. So this means we need to find two numbers that multiply to minus 12 and also add to the minus 1 from the coefficient in the x term. So the two numbers that we need are 3 and minus 4, because if we add 3 and minus 4, we end up with minus 1, and 3 times minus 4 is equal to minus 12. So 3 and minus 4 are the numbers that we need. So this means we need to split the minus x term into 3x minus 4x. So this expression is now 6x squared plus 3x minus 4x minus 2, and we can see that 3x minus 4x is equivalent to minus x from the original expression. So the next thing to do is apply factoring by grouping. We need to put 6x squared plus 3x in the first group and minus 4x minus 2 in the second group. So 6x squared and 3x both have a 3x in common. So we need to take out a 3x from both terms. If we take out 3x from 6x squared, we're left with 2x. And if we do the same with the 3x term, we're left with plus 1. So moving on to our second group, we can take out a minus 2 from minus 4x and minus 2. So if we take out a minus 2 from the minus 4x, we're left with 2x. And if we do the same with the minus 2 term, we're left with plus 1. So now we can see that both terms have a 2x plus 1 term in common. So we'll take out 2x plus 1 from each term. If we take out 2x plus 1 from the first term, we're left with 3x. And if we do the same with the second term, we're left with minus 2. And this is our final answer. Let's do another one. The first thing we need to do, as always, is to multiply the coefficients of the first and last terms, 12 and 4. So 12 times 4 is equal to 48. So this means we need to find two numbers that multiply to 48 and add to the coefficient of the middle term, negative 19. Notice how we want the two numbers to multiply to a positive number, 48, and add to a negative number, negative 19. This means we have to find two negative numbers. The two numbers we are looking for are negative 3 and negative 16, because negative 3 plus negative 16 is equal to negative 19, and negative 3 times negative 16 is equal to 48, and this is what we want. So the two numbers we are looking for are negative 3 and negative 16. So we need to rewrite the expression using the two numbers we found. So we can rewrite this as 12x squared minus 3x minus 16x plus 4. And notice how minus 3x minus 16x is equivalent to the minus 19x in the original expression. So we can factor this using factoring by grouping. So we'll put the first two terms in a group and the last two terms in another group. So notice how 12x squared and minus 3x from the first group have a 3x in common. So if we factor out a 3x from 12x squared, we're left with 4x. And if we factor out 3x from minus 3x, we're left with negative 1. So in the second group, minus 16x and minus 4 both have a minus 4 in common. So we'll factor that out from both terms. If we factor out minus 4 from minus 16x, we're left with 4x. And if we factor out minus 4 from 4, we're left with negative 1, because 4 divided by negative 4 is equal to negative 1. So now we can see that both terms have this 4x minus 1 term in common, so we'll factor that out from both terms. If we take out a 4x minus 1 from the first term, we're left with 3x, and if we factor out 4x minus 1 from our second term, we're left with minus 4. So this factors to parentheses 4x minus 1 times parentheses 3x minus 4, and this is our final answer. So how about this one? Let's factor 5x squared minus x minus 4. So if we multiply the coefficients of the first and last terms, 5 and negative 4, we get 5 times negative 4 equals negative 20. So this means we need to find two numbers that multiply to negative 20 and add to the coefficient in front of the x term, negative 1. So if we take negative 5 and 4, negative 5 plus 4 is equal to negative 1, and negative 5 times 4 is equal to negative 20. And that's what we want. So the two numbers we need are negative 5 and 4. So this means we need to split the middle x term into minus 5x plus 4x. So we can rewrite this as 5x squared minus 5x plus 4x minus 4. And we can see that the minus 5x plus 4x is equivalent to the minus x in the original expression. So now we have to apply factoring by grouping and put the first two terms in a group and the last two terms in another group. So if we look at our first group, we can see that 5x squared and minus 5x both have a 5x term in common. So if we take out a 5x from 5x squared, we're left with x. And if we do the same with the minus 5x, we're left with minus 1. So for our second group, we can take out a 4 from both 4x and the minus 4 term. So if we take out a 4 from 4x, we're left with x. And if we take out a 4 from the negative 4 term, we're left with negative 1. So now both terms have this x minus 1 term in common, so we'll take out an x minus 1 from both terms. If we take out the x minus 1 from the first term, we're left with 5x, and if we take out the x minus 1 from the second term, we're left with the plus 4. And this is our final answer.